Hello everybody, hope you're doing well. So this is my physics presentation. I'd like to draw your attention to these four marine animals that we have featured on the screen. There's a reedfish, a lungfish, a stingray, and a great white shark. And I'd like to ask you, do you know what they all have in common? They have a super cool superpower in common. So they're all able to detect prey that are buried underneath the ocean floor without seeing them. And how are they able to do that? Well, this superpower allows them to sense electric fields. So we're going to talk about that today. And if this will work, there we go. I'm going to move my camera over so y'all can see my pictures better. Okay, so the sensory organs that give them this special superpower are part of a larger class of mechanoreceptors called neuromasts. And these are all part of the lateral line system in fish. So this up here is the general structure of a neuromast and the lateral line system. You can see here there's a channel under the skin that's open to the water. It brings water into contact with the neuromasts that are at the bottom of the channel. The neuromasts are stimulated by the movement of the water, and then the nerves can take that information about how fast the water is flowing and in what direction, and they're able to take that to the brain. So that's your general neuromast lateral line system. So the sense organs that sense electricity are called ampullary sense organs, or ampullae, and they have a little bit of a different structure. So they have a pore that's open to the water, and then they have this vesicle or sac down here that has the nerve fibers, and those are the ampullae. That's where the sense organ gets its name from. But this canal or duct here is filled with a gel-like fluid, and it's super cool, and that's what allows these nerves to be able to sense electricity out in the water. So this fluid is actually a semiconductor, meaning that its resistance falls as the temperature rises. It has a high conductivity, which is super good because that means that it conducts electric signals really well. And it also has the same resistivity as seawater, which is super useful because that means that it will conduct those electric signals down to the nerves without changing the magnitude of the electric field or the potential drop, which is actually what they're sensing. So in sharks, these organs are called the ampullae of Lorenzini. So you might have heard that before, and that's after the man that discovered them. And then since then, scientists have found a lot of other animals with these organs, but they're usually just called ampullae. Okay, so how exactly do these work? So really what they're sensing is a change in voltage. So really these nerve fibers are constantly sending out signals because they're constantly sensing the voltage that the water is conducting. So how do they work in sensing prey? Well, there's a couple of different ways, but we'll focus on one example here. So this shark right here, he's chasing this fish. And this fish, because of his muscle contractions, is generating these electric fields. The electric fields come into contact with these ampullae, with the pores of the ampullae, and then when the voltage difference out here comes in contact with the pore, that voltage difference is conducted through the gel-like fluid down to the ampulla, and then the nerve is able to take that signal to the brain. So these are actually super sensitive. Studies show that they can detect changes of voltage difference up to 0.01 microvolt per centimeter, which is super, super small. So they're able to detect that small of a difference. They do have a very short range, so they're really only effective up to a couple of feet in front of the shark. Excuse me. I hope that didn't show up. Okay. So, yes, so that's what happens. So when this, so say, for example, that this fish, the electric field here is a decrease in the potential compared to the rest of the seawater. Well, that decrease in the potential will travel down the gel, and then they'll reach the nerve. And this nerve, as I said, is constantly sending out these signals, and that's called the spontaneous nerve impulse, and it has a set frequency that it's usually at when the shark is just swimming through the water. When a decrease in the voltage comes along, that decrease increases the frequency that this nerve is firing, and then when the voltage increases, it decreases the frequency that that nerve is firing. So that's how that works. And then that change is communicated to the brain. So there are a couple of different ways that fish will use these sensory organs. So rays in sharks, for example, like this tiger shark here, you can see the holes underneath his nose. Those are the pores of the ampullae. And then you can see down here, this is a cross-section of a shark's head, actually. You can see these different holes are the different pores, and they're filled with jelly. And then these lines here, the white lines, those are nerve fibers. So I thought that was a pretty cool picture. Hopefully it's not too gross. Anyways, but these rays in sharks, what they do is they are able to sense external fields that are generated externally. So if a fish is generating it through its muscle contractions, or if, for example, the Earth has a magnetic field, as we know, that generates small electric fields in the water. So the sharks and the rays are able to detect that. There are other fish that will generate their own electric field, and then when something comes along and distorts that electric field, they're able to sense that change. Okay, so this is super cool. Like I said at the beginning, this is really cool because it allows a fish to detect changes, to basically how they use this to sense prey in the ocean floor is they swim along the floor and they kind of disturb the ocean floor. And then when prey are moving out of the way, their muscle contractions send out these electric signals, and the sharks are able to detect those. So that's how, even though the fish are still, the prey are still buried in the sand, and they're moving through it, and the sharks are able to detect that. Okay, so besides just being super fascinating in and of themselves, these sensory organs are super cool because scientists are studying them to find some applications. So, for example, there are several shark repellents that have been developed, excuse me, that aim at disrupting the shark's ampullae, and it's kind of debated whether or not those work really well or not, but there is research being done on that. And then there's also some engineers that are really interested in using these kinds of organs to develop sensors for robots, to be able to help them know their environments better and respond to them quickly. Alright, so that's my presentation. Sorry, it's a couple minutes over, but here are my references, and I hope you guys enjoyed.